So thank you all for having me. And it is true, I think it was probably Tuesday of last week. It was probably not even that long ago when I reached out to Chuki and Chris and said, hey, I'm going to be in Boulder. I'd love to talk if this is a topic that y'all would be interested in. And whether or not you're interested in it, you showed up. So that's awesome. And maybe by the end, you'll know whether or not you were actually interested in it, which is cool. Speaking of cool, it is rather cold outside. So in the back of the room, I have little Google Cloud beanies that I would love for there to be none in the back of the room when we're gone, because I don't want to take them back home with me to Annapolis. I would rather they warm your heads. There are also some Google Cloud stickers and my business cards in case you want to reach out to me afterwards. I am really excited to be out here and speaking at this group. And I'm going to speak for about 40 minutes maybe. And I definitely encourage you, if you have questions throughout or disagreements, just make those known. And I won't answer your questions, and I'll fight with you on the disagreements. No, that's not at all how it's going to be, I promise. I do have one quick announcement to make before I start my presentation, actually. So there's an event coming up, another event coming up soon called DevOps Days that's happening in Denver, which isn't Boulder. I'm sure you know that, but to me, like Denver, Boulder, they're kind of like I fly to the same airport, therefore they're the same place. And every time I say that in Boulder, people look at me like they want to punch me in the throat. I don't know why. Maybe Boulder is better, is the sense that I get. Anyhow, we are in Boulder now, but DevOps Days Denver is happening in April, at the end of April. The CFP is open. Have any of you been to a DevOps Days event before? All right. An online one, okay. Let me tell you really quickly about this one. It's 2 days. It's a single track, so everyone that goes gets to listen to the same talks. But the talks only last about half of the day. There's a collection of keynotes and Ignite talks. And then in the afternoon, they run what are called open spaces. Has anyone done open spaces before? Or like a bar camp or a food camp or, no? Yeah? Okay. So the way that those work are, you ask and invite all of the attendees to stop being attendees and consumers of content and start being participants in creating the conference experience. So you get invited to propose ideas, topics that you're interested in talking about, and then as a group, you form small groups and go off and have those discussions. The thing that I love about that is it really allows you an opportunity to talk about a deep topic, whether it's technical or culture or whatever, with other members of your community. And it's not just a consumption only, sitting in a chair listening to the person at the front of the room. It's way better when you get to communicate with one another. So if you're interested, if you have a thing that you'd like to talk in the DevOps space, maybe you don't know what DevOps is, I'll give you a definition tonight, and then you'll be experts by the time I'm done talking, and then you'll have a talk ready to go. So that's that. So I wanted to talk tonight about high-performance software delivery and operations, which is a thing that's near and dear to my heart. My name is Nathen Harvey. You can follow me on Twitter if you'd like. You just have to remember to misspell my name like my father did. So Nate, you don't spell your name like this, do you? No, it's totally wrong. Most Nathans spell it Nathan. The rule in my house was mom picks the names and dad misspells them. So myself and my 3 siblings, we all have misspelled names. If you want to know what those are, just find me afterwards and I'll tell you how terrible a speller my father is. And whether I think that's a good thing or a bad thing. And I oscillate back and forth. I'd love to know a little bit about who you are. So this is a talk ostensibly about DevOps and about building and delivering and operating software. So just by a quick show of hands, how many of you consider yourselves like developers, software engineers, application developers, somewhere along that line? Also, you're allowed to vote as many times as you want through these questions, okay? How about like sysadmins, operations people, like we run the systems, okay? Kind of, maybe. Data scientists. I know we have at least one of those in the room. All right, awesome, cool. Let's see, what else? What else are you? What didn't I cover? Students. How many people are students? Man, everyone should raise your hand. We're all learning, right? Therefore, we're all students, right? This is my other trick question. How many of you are business people? Yeah, all of you are. All of you are. In fact, if you're not a business person, then that tells me you don't care about the business that you work for, which tells me you should quit and go get another job because you should care about the work that you have to do every day. And to me, that is kind of what DevOps is all about. It's about caring about what is the business of my business? Why do I get up and go to work every day? What is my mission? Your mission might be to work with a team of peers that you get along with and you trust one another. You love one another and you love working together and learning from each other. That's great. But at the end of the day, that team is there for a purpose. It's there to help serve the customer and help really drive the business forward. And frankly, this is kind of the problem that DevOps seeks to address. So DevOps as a term has been around for about a decade now. How many of you believe you understand what that word DevOps means? Okay, just keep your hands up for a second. How many of you believe that your definition is the same as the other people that have raised their hand? Yeah, probably not. Like, it's weird. DevOps is this weird thing that's been, like, from its beginning, it's been pretty loosely defined. But if we go back in sort of the history of it and really think about what is DevOps, like, what is it at its core? At its core, we go back to the words that create the word DevOps, developers and operators. And, you know, when we go into companies and we talk to developers, we tell developers, we want you to ship features faster, build more features, get those features into the hands of the customer, go faster. But at the same time, we turn to operators and say, make sure the systems are stable. I want 100% uptime. I never want things falling down. Everything has to be stable. And frankly, what happens then is we've misaligned the incentives of these two teams. So developers are there to push, 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 push. Operators are there to stop any changes from coming along. They say no, no, no. And so DevOps was born out of this idea that we have to stop just throwing stuff over the wall out of development and into operations and expecting our operators to run those systems. We have to really align those incentives and remember, why are we doing this? It's for the customer. And so how do we work together to make sure that we're delivering what our customer needs so that we can drive the business forward? And this isn't a new problem, right? We've had this problem since the first line of code was written. We have this idea. We want to get that idea out into the market. It has to touch a bunch of different parts of our organization. So in technology, more than 10 years ago, it's probably 20 years ago or so now, the Agile movement was born. And in practice, what happens with Agile software development is we got our developers much closer to the business, much closer to the customer. And the two of them were working together in a much more streamlined way, collaborating with one another. But in practice, what happened is we were building things faster, but we couldn't consume them on the operations side. We couldn't take them in as quickly. We couldn't run them as fast. And so that created some real problems and some real tension within our organization. So when DevOps was born, it was really meant to solve this problem. How do we keep that flow going through the organization? How do we keep changes moving? And how do we keep those systems up and running? So I want to give you a definition of DevOps. This is how I view DevOps. This is the definition that I adhere to. This definition itself does a pretty DevOps-y thing. It is an open source definition of DevOps. So if you want to change it, you can go and make a pull request against it. If you want to say, if you want to say, I believe in this, like this is how I practice DevOps, you can go and add your name to a README and be part of this DevOps community. But here it is. It's a cultural and professional movement focused on how we build and operate software, born from the experiences of its practitioner. Build and operate high-velocity organizations, born from the experiences of its practitioners. So if I just spend 1 minute on this, it's a cultural and professional movement. DevOps is not a tool. DevOps is not a thing that you can go and buy. It is a cultural and professional movement. Now, there are tools that you will use along your DevOps journey, and some of those tools are common across different organizations. But it's really this cultural and professional movement. So when I think about other cultural and professional movements, things that come to mind are things like barbecue. Barbecue is a cultural and professional movement. Yes, there are tools that you use in barbecue, and everyone uses slightly different tools. How many of you love smoked meats? Yeah, I do. That's good. Or smoked jackfruit, for that matter. There might be some vegetarians in the room. Like, that's cool too. You can still love barbecue. But you experience barbecue in a different way than others do. There are people that are deep into the practice of barbecue, pit masters that spend hours and hours on a daily basis just perfecting their meats. And there are other people that are in this cultural and professional movement of barbecue that just want to eat the meats or eat the barbecue. It doesn't have to be meat. I'm sorry, I'm being kind of exclusive there. Absolutely, it can be everyone. So it's a cultural and professional movement. DevOps also, given that it's not a tool, it's not really something that you can go and buy. You can't go to Google or Amazon or Microsoft or anyone and say, what I'd like to do is buy some DevOps. It's not how it works. Next, it's focused on how we build and operate high-velocity organizations. That makes sense. Build and operate, dev and ops. But the truth of the matter is, with this definition, this definition of DevOps goes beyond development and operations. We're really talking about building a high-velocity organization, and you can't do that by focusing only on two departments. Think about your own journey. How many of you are running in a data center right now, have workloads running in a data center? And how many of you have workloads running in a cloud? Yeah. And how many of you that are in the cloud exclusively previously in your career had workloads running in a data center? So we've all made this transition, or some of us are in the middle of it right now. Some of us have hybrid environments. Those of you that made a transition, did you have to talk to finance about how that transition was going to go? You sure did, right? So finance is part of DevOps. They're part of how do we get into the cloud. You might also have to talk to your HR department. What does HR have to do with DevOps? Well, actually, if you go back to like Agile software development practices, one of the things that Agile really leans on is self-forming teams that come together, solve a problem, and then disband, and you go off and form another team. Does your HR policy allow for that to happen? I know in many places, especially large organizations, like that's no, we have to, what does the org chart look like? This is how we have to incentivize people. This is how we have to work. And we want to break down some of those barriers. So it truly is the entire organization. And then the last bit of this definition, it's born from the experiences of its practitioners. The DevOps that is practiced at Facebook is different than the DevOps that's practiced at Hive, is different than the DevOps that's practiced at Capital One, than at Etsy, than at wherever you work. We all bring a different experience. We all have different customers that we're trying to serve. We all have a different definition of what does it mean to be a high-velocity organization. So in my mind, that's what DevOps is. It is a bunch of practices that we bring together so that we can create this high-velocity organization. The other thing about this is it's a journey. You don't wake up one day and decide, all right, now we're going to become a DevOps organization, and a year later, that's it, we're done, we're doing DevOps. That's just how it is. It's a journey. You're always improving. So in the industry or in our community, there's actually been a lot of research done on DevOps. How many of you have seen the State of DevOps report before? Anyone? One or two folks? Okay. So there's this team of researchers that for the last 5 years, they've gone out and done surveys across the IT community, asking a bunch of questions about their DevOps practices. And they've pulled together all of this research, and they give us a lot of insights into how do we get better at doing the DevOps, if you will. And what they really focus on when they look at DevOps is software delivery and operations performance. So if you look at an organization, how's their performance when it comes to software delivery and software operations? And they break that down into really 4 different metrics. And 2 at the very high level, throughput and stability. So how quickly can we move change through the organization, and how stable are our systems? Your customers care a lot about both of these things, right? Think about this. Your customers want your applications to be working all of the time. Every customer that uses your app, they want it to be there. But also they don't want to use the same app for the next 10 years. They want changes made to that application. They want it to get better over time. And so when we think about throughput and stability, there are actually 4 key metrics that the State of DevOps report digs into. Delivery lead time. So from the time you take your code and put it, where do you put your code? Where does it go? What? GitHub. It goes to GitHub. So your code goes into a code repository, right? What sort of source code repositories do you use here? I hear GitHub, so I know there's Git on the back end of that. Git, yeah? Anyone else use anything else? No? Nobody uses SVN? Used to. All right. Yeah. CVS. What about BAK? Snoozy? Oh, Synergy. Okay. How about BAK? Anybody use that? Did y'all know that one? It's when you copy a file name to filename.bak. Yeah, that's not version control. That's not version control at all. So look, you have to, before you think about moving faster, please make sure that everything that you write, whether it's code or configuration, make sure that that ends up in a version control system. And I say a proper version control system, and my definition of proper is it starts with GIT. So if you check that box, good, you can keep listening. If you don't, what you should do is probably go learn Git and then come back for the rest of this talk. It's being recorded though, so you can go learn Git in the back of the room if you want. It's cool. So delivery lead time. Excuse me, I'm fighting a little bit of a sinus infection. I don't know if I sound a little nasally and a little congested, but I am. Delivery lead time. Time you commit that code to the repository. How long does it take to get into your production environment? What is that time? And then your deployment frequency. How frequently are you deploying? Are you deploying multiple times a day? Are you deploying twice a year? I can tell you that I've been at places where we would print custom apparel when we did a deployment, right? Like custom ball caps or custom t-shirts because version 6 went out. That's not how the industry works anymore. We can't, if we were printing custom apparel every time there was a release, we would spend all of our money on custom apparel, right? But how frequently are you deploying changes? And then on the stability side, how do we actually measure that? We want to look at time to restore service. So when there's a failure, when there's an outage, when there's an incident, how long before that service is fully recovered and restored? And then also, what's your change failure rate? Change failure rate is, I take a change, I put it into the production environment, oh shit, that's a change fail, right? Something just broke, there was an incident, that's a problem, right? So this is another thing that we have to be mindful of and sort of watch out for. And what our research, and I just said that's a lie. It's not my research. It's like people that are scientists and statisticians that have done this research. I may claim it as my own again though, so there's the disclaimer. It's not my research, even if I say it is. What they find is that they're able to take this survey over the past 5 or 6 years, and they break it down. They break down they find groups of people or groups of organizations from low performers all the way through to high performers. And actually in 2018, they introduced an even higher level of performance, the elite performers. So elite performers are 46 times more frequent code deploys than their low performing peers. Their lead time from commit to deploy is 2,500 times faster. These are ridiculous numbers. But what these numbers also tell us, well, these numbers don't tell us, but the research also bears out, is that the elite performers, from a business perspective, also are outperforming their peers that are slow or low performing IT organizations. So the research bears out that software delivery and operations performance is a leading indicator for how your business is going to perform, which kind of makes a ton of sense, right? Your customers want fresh services, fresh things that they're running all the time. They want them to be reliable. And when the market shifts, you have to be able to shift with it, right? So this all, conceptually, I think makes pretty good sense. They've actually taken the last 5 years of their research and put it into a book called Accelerate, Building and Scaling High-Performing Technology Organizations. I absolutely recommend reading this book to learn more about the practice of DevOps and how can you start bringing some DevOps practices into your own organization. And what they found was that there are capabilities that really drive improvement for an organization. And they broke those capabilities down across these 5 different buckets: continuous delivery, architecture, product and process, lean management and monitoring, and culture. And what they suggest is that you look at capabilities across these 5 areas and figure out how can you make improvements on your team to these capabilities. And the impact is going to be, you're going to improve those 4 metrics that we looked at when you focus in on some of these capabilities. So what I'd like to do for the next couple of minutes is take a quick tour just a quick survey of some of the capabilities that are super important. And the first one is continuous integration. Continuous integration. So if we want to be able to move fast and we want to understand what's happening within our code base, we have to have this practice of continuous integration. Now, continuous integration means a bunch of different things. The first thing it means is that when you're writing code, as you write that code, you're integrating it into your mainline branch, whether you call that master or trunk or whatever you call the mainline of your source code repository. When you're truly practicing continuous integration, you make a change, you check it into the mainline, and then a couple of things happen. Your tests are run, and a build is created, an artifact is created. And likely what happens is some tests are run, then an artifact is created, and then some more tests are run. Because based on how you write your tests, some of them are things that you can do before you take the expense of building an artifact, and some you can only do after you've built an artifact. And I'll talk a little bit more about that testing. But the idea here is that you are continually integrating into that main branch. Now, early on in my career, I heard all about continuous integration and said, all right, we're going to start doing continuous integration here. And so this is how we approached it. Spoiler alert, this is the wrong way to approach it. All right, so this is a tale of woe. Every time a developer would start work on a new feature, they would cut a feature branch, and they'd start working in that branch. But we said continuous integration, so at the end of each day, they would take whatever was in the main line, and they would merge it into their branch. So they're continuously integrating master into their branch. That's continuous integration, right? I mean, sure, it's continuous integration that way. That's the wrong way, though, because what would happen is two developers would start two different branches around the same time. They'd go on. They're constantly merging from master. Everything's good. Now this developer merges everything in. Right after merging from master, she rocked it. It was a good feature. Everything's passing. We're moving on. Now this developer is like, all right, it's my turn. Let me merge into master. Boom. Everything blows up. Everything blows up because all of the changes that she made were never being integrated into this branch. We have to be continually integrating. So when you get really good at this practice, your Git branching strategy will be this: no branches. Everything happens right to trunk, or everything happens right to master. How many of you are practicing that today? All right. There is one brave soul, two brave souls here. That's awesome. And then maybe three, or is that a question?
No, that's a question.
Yeah.
So I don't know how old this is, but there's this process called git flow,
Yes.
which is sort of the opposite of what you're suggesting. What are the good arguments against that besides, say, the thing that you just said?
Yes. So
could I point to say, git flow is probably not what we should be using?
Yeah. What I would say, so the question, if you didn't hear it in the back, there's this process called git flow, which is another practice that you might have, a branching strategy around Git. And with git flow, you basically create a bunch of release branches, and you're constantly merging to those release branches, and they're always kind of moving forward. One of the biggest challenges with that, frankly, is just looking at your code base and having the context of what's in production right now, right? And we have these multiple branches. What are the deltas between the branches? You start bringing on a lot of overhead to clean up and make sure that you're merging those branches properly. The thing that I would really point to, though, is just the huge body of research that bears out that trunk-based development is the best and safest way to do your development. There's another interesting thing, like when you get really into continuous integration, there are a couple of other patterns that come out. First, of course, just always working on master or always working on trunk maybe isn't feasible. Maybe there are branches, but those branches should be very short-lived, like 24 hours or less, and the developer that's working on those branches shouldn't go home until they're merged. Now, I say that not because we should treat our developers in an inhumane way. You should let your developers go home at night. But we really need to be integrating that back in. And then the other thing that's really interesting right now, this is kind of a perennial debate also, microservices are spinning up. So now none of us run one application. We run hundreds of applications or hundreds of services. So how many Git repositories do you have? Do you have one per service, or do you have one Git repository? And the mono repo maybe is the safest, best way to go. Of course, it introduces some challenges relative to not having a mono repo, It's a debate that comes up all the time in the community. You might know that Google is a huge practicer of the mono repo is the way to go. Also, you might argue with me, I'm not Google, so I don't have to do that. And it's true, you might not be Google, but I think you would find a lot of benefit in a mono repo. We could actually spend, I gave myself 40 minutes, I have 15 minutes left. I could spend the next 2 hours talking about this and going back and forth. To those doubters, those people that fall in love with Git flow, the first thing I would do is say, look, if it's working, great, keep doing that. Are you still making progress? But when you find pain, it might be a thing to look at, and then I would look at the body of work around why trunk-based development is better. Automated testing. So when we're continuously integrating, we are also running our tests. This means that our tests have to be automated. How many of you have a QA department where you work? Yeah. It's okay to have QA engineers. Having a QA department, I think, is kind of a problem. The big problem with that is if I'm the developer and there's a step between me and production that is QA, like their job, their incentive is to find the bugs. My job is to write the features. I write the features, I hand it to QA, they find the bugs, and then it comes back to me. And if we get into that cycle and that practice, like that is a recipe for disaster for sure. Now, if you are a QA engineer and you're proud of your QA department, I just encourage you to change how you think about what your job is. Your job is to ensure that there's quality baked in to the software from the beginning. And the best way for you to do that is to not stand over here on the side waiting for the developers to hand you stuff, but go sit next to the developers and coach them on how to write better tests. Coach them on how to build better automated tests into their workflow and into their systems. So we're going to move faster. We're going to continuously deploy things. We cannot do that if we don't have good testing that will tell us that the closer we get to production, the safer we are. That's how we have to feel. So automated testing, super important. Along the same lines, we have to shift left on security. So what does that mean? Again, if we're going to build quality into the product, we're going to build security into the product. How do we understand the security profile of this system? Now, if in your experience, operations has been like the Department of No, let me introduce you to security, because that is truly the Department of No. The interesting thing I find about security professionals, if you go back, 5 years, or maybe if you go back to earlier today, depending on where you work and the profile of the security engineers in your team, 5 years ago, in my experience, security professionals were like, this system is secure because I put my hands on it and I secured it. Therefore, I know it's secure. Whereas today, we have to have automation for that security. We have to build that security into how we provision our infrastructure, all of the things as code that we do. We have to do that with security as well. And there are a lot of security professionals who will hear that and say, you want to do security as code? I'm not a coder. I'm a security professional. I'm going to protect your systems, and I'm going to do it my way. It's not really scalable, and it's not really going to work. That's not to say that we don't need security engineers. Of course, we need that discipline, but we need to apply that discipline in a different way. We want to get that into the pipeline as early as possible. All of this is so that we can implement continuous delivery. And implementing continuous delivery truly means that as you want to get as close to possible as a commit makes it all the way through to production. Each change that you make to your repository goes all the way through to production. That's not to say continuous delivery doesn't necessarily mean you commit it to the repository, no human ever looks at it again, now it's in production. There may absolutely be human gates along that process. There may be code review that you get from your peers. There may be a product owner that signs off, we're ready to ship this feature. Who knows? But to truly get to every commit makes it into production as an independent release, you also have to start thinking about the architecture of your systems and sort of how you're building out those applications. Can you do things like canary deployments, where you deploy to a small set of your users and see what happens, make sure it works well before you push it out globally to everyone? Because you want to sort of minimize the blast radius of any change that you put out and increase your confidence in that change over time. You also might start thinking about things like feature flags. So as a developer, I'm building a new feature. I give my operators the ability to toggle that feature on and off, or to slowly roll that out to a subset of users. All of these things change how you're developing your applications and change some of the infrastructure as well. So things to consider. But if we get to this point of continuous delivery, like I feel like we've done pretty well on that throughput thing, but we haven't really talked much about the reliability side yet. And the fact of the matter is that most of the software that we're writing today is going to spend more of its time in an operational or production environment than it is in a development environment. And if you're a business owner, that's exactly what you want. Of course, you want to be building features very quickly, and we want to spend as little time as possible on development. And we want those features to go into production and make us money for years and years to come, right? The truth is, that's how software works. It spends way more time in an operational environment. I've been around long enough that I am sure there is code running on a production system right now that I wrote that was a quick fix that we're going to come back to and fix next week. Any of you have that experience? Yeah. How do you think that how do you think that code maybe exposes you to new security vulnerabilities as well? Like it's frightening to think about some of the code that runs in production. Actually, it's mind-boggling to think about how does any of this actually work, because I have no idea. So SRE, or site reliability engineering, is a thing that's kind of very close to DevOps. They're kind of maybe cousins, if you will. But site reliability engineering, or SRE, is really a thing that Google sort of built internally, and a couple of years ago we started talking about it outside of the building, outside of Google, and are really pushing this. And it lands really well within the DevOps community, whereas DevOps, as I described it earlier, has a pretty broad and pretty loose definition. There are some very strict practices within SRE that really provide a nice framework for how do you actually implement some of this stuff. And so the SRE is really an approach to operations. Whereas a lot of people think of DevOps, I disagree with them, but a lot of people think of DevOps as just continuous delivery, so just the delivery side of things, not the operating side. They forget the second half of the word somehow. I think SRE is way more focused on the operations side. It does play a little bit into the delivery side as well, but it's really about how do we treat operations like it's an engineering problem or a software problem. And it starts with this basic tenet. 100% reliability is the wrong target for any system. And if you think about this, as a business owner, what you want is 100% uptime, 100% reliability for all of the systems that you're delivering to your customers. But as technologists, if you think about what is the cost, both the physical, like the dollar cost that we're going to have to pay to build systems like that, the human costs that we're going to have to build systems like that, monitor them, treat people in inhumane ways to make sure that we meet these goals, like it just doesn't make any sense. And anyone that's running mobile applications, like how many of you have mobile phones that are 100% uptime, 100% connectivity? Yeah. So it does, even if your application was 100% available and you run it on a mobile phone, it's not 100% available. And it's out of your control. You can't get there. So the practice that SRE introduces is this idea of error budgets. And I want to talk a little bit about error budgets, because error budgets really are meant to balance this idea of throughput and reliability. So an error budget is this. You think about a target. Maybe it's availability, or maybe it's latency, or maybe it's throughput on a system. We'll stick with an easy one. Let's say it's availability. Your systems could be available, your uptime could be 100%. We know that's not what we want. It's not what our users want. So you then figure out from there, what do our customers actually care about? As a business, it's easy to say, I want 5 nines or 6 nines or 8 nines, but stop for a minute. What do your customers actually want? What is the uptime that they actually care about? And you set that as your service level objective. So maybe what you come up with is, I have 99.5 or 2.5 nines is going to be my service level objective. And everything between those 2.5 nines and 100%, that becomes what's called your error budget. And when you start managing your systems and thinking about your error budget, a bunch of things can happen. The first thing that's important is that you get everyone on the team to agree to what that error budget is. And by everyone, I mean your operators, the people that are responsible for running those systems, your developers, the people responsible for building those systems, your product owners or the business side, the people that are responsible for making decisions about what do we ship out. Once we've all agreed on what our error budget is going to be, we can then use that to start measuring our systems. When we think about how many of you have ever been woken up at 3 a.m. For a system problem? Yeah. And of you, how many of you have ever been woken up at 3 a.m. for a system problem that didn't matter at 3 a.m.? Yeah, all of us, right? Anyone who's ever been woken up at 3 a.m. has been woken up, guaranteed, for a reason that actually didn't matter. You didn't know that at the time, but it turned out not to matter. When you start managing your systems with error budgets, you can now stop alerting on things that probably don't matter. I've definitely been woken up, because a CPU is spiking, or because one instance in a cluster fell over. None of those things actually matter. It didn't have an impact on availability, but it woke me up. So we think about those SLOs, or that error budget. If we start consuming the error budget, now I want a human to take action to help preserve that error budget. And so we can align all of our teams through these error budgets. And the agreement that you come to is when I'm consuming my error budget, when I've exhausted my error budget. So I said 99.5, between 99.5 and 100, that's my error budget. When I've been down such that I fall under 99.5, I've consumed all of my error budget, we now have an agreement that as a team, we will stop building new features and we will put all of our engineering efforts on things that make the system more reliable. And those SLOs, that error budget, maybe lasts, you have a time bucket with it. So maybe it's 99.5 over the trailing 28 days. So as soon as you get into those 28 days, as soon as you've consumed that budget, you stop. And until you build that error budget back up, what you focus on is reliability. That reliability might be updates to your pipelines, so you have better testing capabilities. It might be updates to your production infrastructure so that you have better failover capabilities. Whatever those things are, that's where you put your engineering effort. And here's the other thing about them. If you find not that you're consuming your error budget, but that you're always coming in way under your error budget, that's an indication that you aren't experimenting enough. You're not moving fast enough. You could actually put new features out faster to your customers to get feedback on those features faster, to improve your product faster, to learn faster. So you really use this error budget to balance those two things. If I've consumed too much of it, we slow down. We work on reliability. If I'm not consuming enough of it, we should move faster. How do we build features faster? How do we get them out to our customers faster so that we can learn better? So as you think about improving your software delivery and operations performance, these are some great things that you can start measuring. Start measuring, if you aren't already, your delivery lead time from commit to deploy, your deployment frequency. Are you deploying once a day, 100 times a day, once every 2 years, whatever that is. Time to restore your service, when things fall over, and things will fall over. How quickly do you react to that? How quickly can you get your systems back? Your change failure rate, and then those error budgets. And when you stop and think about this, none of these are purely technical things that you can go and fix. You can't apply a tool and fix any one of these things. All of them are a mix of technology and the way that we work together, the way that we collaborate, the way that we interact with one another. All right, so just to wrap up really quickly here, I'll leave you some homework. Go read the Accelerate State of DevOps report. That started, I think it started in 2013 was the first version of the State of DevOps report. But basically 2013 through 2017 are summarized in the book Accelerate. So you can read the book. It is available as a book on tape also, or like an audiobook. Book on tape. Sorry. It's available as an audiobook. So if listening to it is your jam, you can totally do that. Super interesting stuff and great information there. But Accelerate kind of summarizes all of the State of DevOps report through 2017. So you can think of the 2018 State of DevOps report as like an appendix to the book. Go and check that out. It also talks about, in the 2018 report, it also talks about like adoption of cloud and how that impacts your software delivery operations and performance, or delivery and operations performance. It also talks about things like outsourcing. What are you outsourcing to other like third parties in your technology infrastructure? And how does that impact operations and delivery capabilities? Here's the hint, it's not good. Like, you probably shouldn't outsource that, keep that inside. And then to read more about SRE and site reliability engineering, there are 3 different books. They're all published by O'Reilly. And 2 of the books, the first 2 there, the Site Reliability Engineering book and the Site Reliability Workbook, are both available for free to read online at the URL that's there. The Seeking SRE is not available there, but the SRE book outlines everything about SRE. The Site Reliability Workbook says, okay, you want to get started with error budgets. How do you even set an error budget? You want to get started with better postmortems. What does that even look like? And it truly is like get started with, because I can tell you that if you set an error budget today or set some service level objectives, you set the wrong ones. Actually, they're the right ones for now, and you're going to learn and your systems are going to improve and you're going to change them over time. So don't feel like I'm going to set it once and a decade later it's going to be the same thing. It's not that. And then Seeking SRE is a collection of essays and conversations from folks that are out there in the real world doing SRE work. So it's a good thing to check out. With that, I want to say thank you so much. We don't have to leave immediately. I'm totally around for questions if you have them. But just a couple of quick reminders. You maybe thought you came here tonight to listen to me. I would argue that you came here tonight to meet one another and help build this Boulder community. So thank you for coming out, and do take some time to meet someone else while you're here. And don't forget, I have caps at the back of the room for you, so leave here with a warm head. Thanks very much.